Okay, this is a continuation of section 2.3 for MAC1105, and we were looking to find the equation of a line using a slope of -3/5 and passing through 10 -4, and trying to give that equation in both point slope form, which we had done in part A. We had y plus 4 is equal to -3/5 times x minus 10, but I have already started using this in order to get part B. When you want to give the equation in slope-intercept form like this, you need to get the y by itself, especially if you don't have a picture where you can just see what the y-intercept is and put it right there and use the slope that you already had for the previous answer. Then that means you have to go this route. You have to take what you ended up with for an answer, which was this. We had this for our point slope answer. I then began working on this to get the answer for part B by I'm trying to isolate for y just like this formula looks right here. And I did that by subtracting the 4 away from it, and therefore I had to do it on the other side as well. So let me move this in a little bit. Running out of room here. So I'm working on my previous answer. And I also decided that in order to combine -4 with the terms that are here, that I needed to get rid of these parentheses. So I'm in the process of doing that. -3x, -3/5 times x is -3/5 x, and then -3/5 times -10 is right here. Haven't done that calculation yet. So we're at this point right now where we have -3/5 x. And then this would be -3 times -10. This times this is 30. 30 divided by 5 is 6. Minus the 4 that's over here. I'm almost there. So this will be equal to y is equal to slope times x, and when these are combined, they would represent that b value, the y-intercept. So just a way to get into the answer without actually having a picture to make it a little bit easier on us. So we have the point slope form of the equation. And we also have the slope-intercept form of an equation. And they're going to ask quite a few questions in MyLab Math where they're going to ask you to give both. Okay, it says, I think I was just trying to give you some pointers there. If you are not given the slope, you will always be given 2 points that will allow you to find the slope. We've already gone through some problems like that. Points can be given in the form of an x-intercept or a y-intercept, so it's important to know how to take those intercepts and write them as a point with 2 coordinates. I already had an example for that. Using the graph in the previous problem, name the y-intercept. So not in this problem, but the previous problem, the y-intercept, name it as a point. Well, this was the previous problem. There was the picture, and the y-intercept was 0, 3. And what is the x-intercept? Just so I think I asked this question just so we're reviewing the fact of recognizing a y-intercept as well as an x-intercept, because these points sometimes have to be used in order to find a slope. X-intercept is right here where it runs through the x-axis. That's called 2, 0. Now find the slope using these 2 intercepts, because a lot of times they leave you on your own, and sometimes you think you don't even have enough information to find the slope. But again, intercepts can be used to find the slope. So your slope in this case would be, I'll write the formula so that we're working on memorizing these things. So the y values here would be 3 and 0. I'm going to go from here to here and stay consistent with that. The x's are 0 and 2. So this will be 3. 3 take away nothing is 3. 0 take away 2 is -2. And you can put that negative floated up to the top, leave it off to the side, whatever you want. So the slope is 3 halves, negative. Okay, moving on, make sure that you were able to see all that work. Where I went this y minus that y right there on the top and got a 3. And where I went this x minus this x on the bottom and got a negative 2. For that final slope of negative 3 halves. Okay, moving to the next page where we are doing finding the equation of a line that passes through this and has an x-intercept of negative 1. First, think how to write the x-intercept. X-intercept means it goes right through negative 1 on the x-intercept, and the y value is 0. Okay, then if you wanted to do the slope, it would be the y's subtracted over the x's subtracted. So the y's would be 0 and negative 3. And the x's would be negative 1 and 1. Negative 1 and 1. This would be 0 plus 3 or just 3. This would be negative 1 take away 1. Negative 1 combined with another negative 1 is negative 2. Same thing we had on the previous page because it's the same problem. Okay, then give the equation in point slope form and also in slope intercept form. So if we give it in point slope form, it's y minus y1 is equal to slope times x minus x1. And we have to choose which point we're going to use. We can either use the intercept information or we can use the 1, negative 3. I'm going to use the intercept information because that has an x1 and a y1. So it would be y minus the y coordinate is equal to the slope, which we found twice actually, previous page and here. And we're going to go x minus the x coordinate, which is negative 1. This serves as x1, this serves as y1. Okay, if we clean this up a little bit, this will be y take away nothing, would be just y. And then we don't really need to carry this 3 halves right through the parenthesis, not when you're giving it in point slope form. And then inside here would just be x plus 1. Okay, so it just so happens because of the x1 and the y1 that I chose that we ended up getting just y. Y take away nothing was just y. So we actually are very close to having this in the form that they are asking us for in part B, the slope intercept form. So this will be my point slope equation where I can just leave the parentheses in. And then if I want it to look like what they're requesting in part B, slope intercept form, that's the formula right there, that you isolate the y. Already done that. The slope will be in front of the x term, and then you will show the y-intercept as your constant. So here we go with that. It's going to be y is equal to negative 3 halves times x is negative 3 halves x. And then negative 3 halves times 1 is negative 3 halves. So there we have it in slope intercept form. Okay, equations of horizontal lines. Whenever you're running a horizontal line, that means every single y value on the line is the same. So you want to give the equation of a horizontal line, just y is equal to, consistently y is the same value on any horizontal line. So for instance, here, if you wanted to graph this equation, you need to isolate y by bringing the 10 to the opposite side. So 7 minus 10. And then getting the negative 3. So you're going to graph a line where y is consistently negative 3. So you could plot the point 1, negative 3. You could plot the point 1, 2, 3, 4, negative 3. Just a bunch of points where the y value is negative 3. We could go to negative 2, negative 3. And you'll see that all of these points will line up in a horizontal fashion. Whoops, guess I didn't allow you to see the graph. So I isolated y by bringing the 10 to the opposite side, which made it negative 10. That gave me y is equal to 3. So what I just did is plot several points where the y value is 3. I plotted 4, negative 3, and you could have picked any point you wanted. I picked 1, negative 3, and I also picked negative 2, negative 3. So anything would have been good, but everything on this line has a y value of 3, negative 3. Here is another equation where x is constantly a particular value. And if you, again, whenever you're missing one of your variables, either the x or the y, here x was missing. So the one variable I did have, I isolated it. This is also called a constant equation. Y is constantly negative 3. So every point that you plan is going to have that y value, but the x is whatever variable is missing, that variable can be any value you want. And that's the same thought process here. If you were to bring this negative 4 to the opposite side, it would be a positive 4. You've then isolated the one and only variable you have. Negative 2 plus 4 is 2. So you're just going to plot a bunch of points where x is always 2. There's no y in this equation, so y can be whatever you want. So you could plot 2, 0. You could plot 2, 1. You could plot 2, negative 3. Anything you want, but just consistently have x being 2. And you'll see that this is a vertical line. Just like that's a horizontal line, this is a vertical line that runs up and down. But you'll see that as you plot these points. So 2, 0 would be right there. 2, 1 would be right above it. 2, negative 3 would be down here. And then you plot these points, and every single thing on this line would have an x value of 2, just like every single point on this previous line had a y value of negative 3. So those are equations and graphs where one of the variables are missing. All right, let's see if there's anything else here. General form for the equation of a line. That is when you have all terms on one side and it's zeroed out on the other side. So for instance, if they say find the equation of the line that passes through 2, negative 5 and has a slope of 3/4, and they ask you to write the equation in point slope form as well as general form, this would be point slope form. Y minus y1 is equal to slope times x minus x1. So this would be the y value, just y, minus the y value here, which is negative 5. Your slope is 3/4. And then it's x minus the x coordinate. This serves as x1, this serves as y1. And where you see a plain y and a plain x, you just write those variables because you need both those variables in the equation. So the x coordinate would be the 2. And you can just clean this up a bit, but leave it with the multiplier out in front of the parentheses in order to give your point slope answer. Your point slope equation. Then if you want to get that equation in general form, that means that you're going to get everything on one side. You should get rid of the fractions and in order to zero this out. So first thing I think I'm going to do is take this and multiply everything by 4. Okay, this was part A. And then for part B, I'm going to copy the equation and multiply. I'm going to end up multiplying everything by 4 to clear out the fractions and then get all terms on one side. Even let me move this over here a little bit. Okay, so just to get rid of this fraction here, I'm going to multiply this whole equation by 4. So this would be 4y, and then 4 times 5 is 20. Then I'd be multiplying this by 4 as well. But what would happen on this side, now don't use that 4 too many times. This 4 cancels with this and leaves us with 3 times x minus 2, which then turns into 4y plus 20. is equal to 3x